Okay, so basically, this is our project. It's an agentic holographic GNN for multi-relational track repurposing. We are using graphical neural networks because medical data has a like it is very huge, and we need to find each and every relation when it comes to medical. So we are using graphical neural network, which is way more stronger than any other neural network or ML algorithm. And what basically is drug repurposing? Drug repurposing is that to enhance the efficiency of the existing drugs. So basically, like each and every drug will not have a dedicated, like each and every disease will not have a dedicated drug, right? So and it cannot be formed also. So for many diseases, a drug may cure, like that a single drug may cure several other diseases. So that is what we are working on. That analysis is what we are working on to increase the efficiency of an existing drug as much as possible, so that the need for inventing a new drug becomes less. And for inventing a new drug, or for a drug discovery, it needs a lot of time and a lot of effort. So here in our model, we have a shared embedding. It's an holographic embedding where it captures all the relations and associations. Like all the relation associations here means the drug-drug association. Like for side effect analysis, like if you are taking another drug already, then it should like analyze the side effect of taking another drug also, right? So it like both the drugs should interact in a good way, not in a bad manner. And then drug protein interaction, the protein inside a like inside a body for biological mechanism understanding, and a drug disease association for drug repurposing. And then it's like this is what I told all about. Like drug repurposing is a very cost effective strategy for accelerating discovery, but like identifying the new creatives from the existing drugs. So this is very important, from the existing drugs. So here we are having a unified multitask learning model, which will cover all these three association, as I already mentioned. It is called a holographic embedding because it captures multiple views, like all the relations it captures and stores in the embedding, that is the drug disease, drug protein, and drug interaction. And then on top of it, we are integrating it with the agentic AI for the user friendly environment. The users can give a prompt of whatever they feel and whatever they are having, and the issues and the current medical condition they are having, and we will get a proper reasoning, and the users are kept well aware of what their body condition is, what needs to be done after, and all. So basically, we're using GNNs plus holographic embeddings and an agentic AI for a unified biomedical prediction. Okay, so now let's go to this graph creation. So for purpose of graph creation, we are taking data sets from drug data from the drug pack data set and the CTD data set. These are huge data sets because biological data sets are always huge. So all these are analyzed, and we are forming three dedicated edges for forming the graph purposes. These edges are drug protein edges, drug disease edges, and drug edges. Drug protein and drug edges are formed from the drug bank dataset, and drug disease are formed from another dataset. So here we are using this drug bank full database, and we are finding the total interactions extracted. Like these are the drug IDs, and these are protein IDs, and this is the drug name. So basically, we are forming the drug protein disease now. Sorry, protein edge now. So drug protein edge. It's saved as CSV format. So it is done through drug bank, and these are the sample rows that will be there, as we already saw about drug ID, drug name, and the protein ID. And then now again for the drug interactions, like it is processed this much drugs and this much interactions are quite a lot of interactions, quite like process a lot of drugs. As you can see, I'm keeping scrolling. So yeah, again it process and the drug interactions found from the same data set, that is the drug bank. These are the DDIs, that is the drug interactions that are found. So these are the edges that are being formed. So our model is reliable because of so much data. So now the drug edges also form, before we form the drug protein, now the drug, and now from the CTD we will form the drug disease. So these is how the CTD data set will be, and now the drug disease edges are formed with the help of this. So now we are having this edges, like this much number of edges. Now we go into the actual we are loading all this data into RVS code for coding purposes. So we are loading its CSV format. This is the drug disease edges, like the chemical name, disease name, and the direct evidence it have. It's a very very large data set that we are importing it here. So it's very difficult to scroll one by one. So I'm just scrolling down. So we have around this much data, so it is very 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 huge, as you can as you can see. So it's very huge. So now next we have the uh, drug edges, which will save the interactions. So this interacts with this. So it is the drug ID one, drug ID two, and the relation. So this also is a very very big data set, as you can see. So yeah, we have around so much of data. And then this is the drug protein edges that is being formed, drug ID and the drug name and the uniprot ID. So this is also a quite a big data set, but yeah, not that much big. Now comes the SRC folder where our code, actual code is. So this is our agent .py file where we run the LLM from, like, the LLM operations are done from this code. So we are calling the LLM from here, and this is the data loader where we load all this about three CSVs and then get like information and then give the appropriate result for each and every prompt. And these are the predictions. This prediction will be based on the score. And then this is the graph builder. Like, we have edges separately, like these are together formed into a single unified graph. So everything is done here. And then this is the LLM part. We are using Grok API here for API keys, and model is Llama 3.18b instant. And then this is the encoder model, GNN encoder, and a link predictor. We have a separate class for each of it. And then this is the pre-processing, like just the cleaning process of the CTD data set. That's like we are having only the required columns, not everything. This is the query engine. This is what runs whenever we give a prompt, like whenever we give a prompt, it extracts the relevant nodes from the graph based on the user input. So this is the training code where we train the entire data, and this is the utils that is being done here. And this git ignore is for GitHub process and all. This is our config dot py file, and then this is an application file. This is what we are running using Streamlit. So whenever we run, this will be printed. This is not a medical advice, consult a doctor, because we are not giving a thorough medical advice. We are just giving suggestions, and we are just helping the patients out to know what their condition is. So these are the requirements of the project. So I've already run the Streamlit app now. So we'll be seeing what we get. So I've already given two prompts. We'll just see if this is not a medical advice, consult doctor, and this much notes are noted from this much edges. So now first prompt I've given is I'm having fever, headache, and fatigue. So I'm already taking Dolo 650. So now it will do a complete analysis and give you the possible diseases that you may be suffering from, and these are the other symptoms that might be there. So this is the suggested medications, like given your current medication, based on your current medication it will give you the suggested medications that may be considered. These are the drug interactions. So since you're already taking Dolo 650, be cautious while the follow with the following instructions. So this precaution is also given. Other than that, the other precautions are given, like to stay hydrated, to avoid excessive alcohol, and monitor liver function. So it will give you when to see a doctor also, because medical advice is not a joke. So we have to be very serious. So you have to consult a doctor on severe conditions. So it will give you when to see a doctor also. Another prompt is that I'm having a itchy skin and burning sensation. Is it because I travel a lot in sun, high temperature outside? So it will give an analysis for that also. So it'll give burning sensation possibly due to sun exposure. So these are the possible conditions that might be there. And the suggested medication again. So we did not give any drug interaction. So please provide any medication you're currently taking so that I can check for potential interactions it is giving. And the precautions again, like what stretching, we have to moisturize well, and when to see a doctor. So for real, like I can give you a prompt now to give you real time experience of how this comes. Maybe we will give, I am having swollen leg. I am already having diabetes and taking insulin. Okay, diabetes spelling is wrong, which is correct. Diabetes and taking. Let's see what it gives. Uh, yeah. So now we are just having the analysis. So it can be the symptom of several conditions. Given that the history of diabetes, it's essential to consider the following possibilities. These are the following possibilities that might be there, and these are the suggested medications. Drug interactions. Given that you are taking insulin, consider the following potential interactions. So these are also given. And then the precautions: monitor the blood sugar, watch for signs of infection, avoid self medication. So this is very important. So as I already said, this is not a medical advice, it's not a joke. So it will give when to see doctor also. So yeah, this is our clinical AI assistant that will give you, like, that will keep you informed and aware about your body conditions, and to take precautionary measures before anything serious happens. Yeah, thank you.